Good afternoon, class. Today we're going to be looking at, this is the first assignment that has the graphing tools that are built into Pearson MyLab. We'll be looking at rectangular coordinates and graphing, and I need to remind y'all of what I mean by a rectangular coordinate system. A rectangular coordinate system consists of two number lines, a vertical number line, and a horizontal number line. The vertical number line is most frequently called the x-axis, and the horizontal number line is called the y-axis. Just like with any other horizontal number line, to the right is positive, to the left is negative. With a vertical number line, up is positive, down is negative. The point of intersection of the x-axis and y-axis corresponds to 0 on both of these number lines. So as I said, to the right is the positive direction. To the left is the negative direction. Up is positive. Down is negative. These two number lines divide the plane. A plane is a flat, anything flat surface. For our purposes, it's this sheet of paper I'm writing on. The number lines divide the plane into 4 distinct regions called quadrants. The upper right-hand corner, that's called quadrant 1, and it's numbered with a Roman numeral 1. And the quadrants move in counterclockwise order. Here we have quadrant 2, quadrant 3, and quadrant 4. We can refer to any spot on this XY grid using something called an ordered pair. For example, this point right here, that spot right there on the XY grid. You always start at the point of intersection. This point of intersection is frequently called the origin because that's where all your movement originates from. To get vertically positioned underneath this point, you'd have to go 2 units to the right. So we say the x-coordinate of this ordered pair is 2. You then have to go 3 units up to actually get to that spot, so the y-coordinate is 3. So this little spot right there, we can refer to it using the ordered pair 2, 3. It's called an ordered pair because the order in which the numbers is written is important. 2, 3 is not the same thing as 3, 2. Now point 3, 2, you'd have to go 3 units to the right and then 2 units up to get to that desired point. Okay, y'all tell me, what do y'all think, how would we refer to this point right here? Okay, we'd go 4 units to the right and then 1 unit up. So I agree with the ordered pair 4, 1. Let's move out of quadrant 1. Let's move somewhere like right here. What would be the coordinates for that point?
-4 and +2.
Okay, so you'd have to go 4 units to the left to get positioned underneath that point. So I agree the x-coordinate would be -4. You then have to go up 2 units to actually arrive at that spot. So I agree with the ordered pair -4, 2. What about this one? What about that point right there? What does it look like to you? Now realize We're assuming these are integer coordinates because the naked eye couldn't tell the difference between -2 and -2.00147. So in terms of integers, what does that look like?
-2.
Okay, so the x coordinate would be -2 because you have to move 2 units to the left, and then vertically, +5, I agree. What about this point right there? What would that spot be in the third quadrant? Okay, I agree. You'd go left 5, so the x coordinate is -5. The y coordinate, you go down 2, so -5, -2. And
go ahead and
one
do one over
more
here just to beat that horse.
Which I'm going to do right there. What would this point be? Okay, you'd have to go to the right 2 and then down 3. So I agree with +2, -3. In general, we can notice some signs for points that are in quadrants. Every point, every ordered pair in this upper right-hand corner, you'd have to go to the right and then up. That means in quadrant 1, the x coordinate will always be positive. What about the y coordinate?
Positive.
Okay. To the left, to quadrant 2, you'd have to go left and then up. Since you have to go left, what does that mean about the x coordinate? Negative, and then positive.
I'm reminded years ago of a teaching trigonometry and a student asking, we were filling in this plus and minus, and a student in trigonometry asked, are we supposed to memorize this? It was a hostel student. And I was like, well, I don't really think you memorize it. You just sort of know it if you know how this stuff's set up. What would this one be here?
We go left and down. You tell me the signs.
Negative.
Negative. And in quadrant 4, every ordered pair will have the signs. Positive, negative. What about points that are on the axes? Let's look at this point right here on the x-axis. What about ordered pairs on the x-axis? I want to refer to this spot right here using an ordered pair. What will my x-coordinate be? I have to move 2 units to the right, so I'd go +2, but what's the y-coordinate? 0. You don't want to go up or down. What about this point right here? What would that be represented as an ordered pair? So you go left 5, but what do you do about up and down?
0.
You're not going to go up or down. It's a 0. Points on the x-axis are referred to as x-intercepts. The x-intercept is a point on the x-axis. And if a point is on the x-axis, every y-coordinate has to have what number? 0. If the y is anything other than 0, you're not going to be on the y-axis. You're going to have moved up or down. On the x-axis. So a point on the x-axis, it has to have a y value equal to 0. That means if you're looking at an ordered pair on the x-axis, it's going to look something like that. You'll have a number here, but the y-coordinate has to be 0. Let's apply that same logic to ordered pairs on the y-axis. Here, give this point to me as an ordered pair.
0, 4.
Okay, so you don't go left or right. So your x-coordinate has to be 0, but then you move up 4 units. What about this point right here? 0, -2. Apply that same logic we used a moment ago for the x-axis, apply it to the y-axis. In order for a point to be on the y-axis, you can't go left or right. So what has to be true about every x coordinate on the y-axis? It's equal to 0. A point on the y-axis is called the y-intercept. That's a point on the y-axis. And if it's on the y-axis, the x value will have to be 0. That means you expect the ordered pair to look like that. The x value is 0. The y value is some other number. Any questions there?
Well, if
We're
this picture doesn't make it clear,
Nothing will.
nothing will.
Nothing will. That picture.
Says it all.
Hmm.
I'm thinking back to before the lectures were recorded. If you wrote this down and you're looking at it, oh my gosh, what the
I
heck
will
is it
know it,
saying?
Tony. We're going to be graphing
Student.
5 general shapes, Tony. We're going to be graphing 5 general shapes. So let's see. I think I'll Roman numeral them. The first thing we're going to graph, the most basic graphing equation, is a line. A line can be written in the form ax plus by is equal to c, where a, b, and c are real numbers. A, b, and c are numbers. The letters, the variables, are x and y. Notice there's no x squared, there's no y squared. In order to use the graphing tools, you have to know what you're trying to graph. You're not going to be able to just, the graphing tool, you're not just going to type in the equation and it graphs it for you. You have to look and see, oh, that equation doesn't have any x squares or y squares, no exponents, no fractions, then you know that it's a line. Let's look at number 1. Uh-oh, we're in trouble. This is the one
You
of those.
lost the Delmark and your
My little.
hotspot is trying.
One day I'm just gonna have to. I have been looking at that Samsung Galaxy S25, so I'm thinking maybe it's time. What do you think? Every 5 years buy a new phone? Does that seem sensible?
Okay.
At this point, I've had it so long, it's just a matter of pride, okay? How long can I keep it? It's not that car we're in. I never dreamed we'd keep a car for 15 years.
But we drove it to work today, got it out of the
To
garage.
celebrate, 15 years ago, we bought that car. And I
15
remember
years ago yesterday.
yesterday, I remember thinking once we were buying it, so we'll just keep it maybe 3 years. Yeah, we're not going to keep this thing for very long. But we'd had flashy cars, and we would get stopped by the police.
Yeah.
And so I wanted a generic car that no one would notice. Never been stopped.
And you
in this
knew
little
after a year or
generic.
two you were going to give it to your mother.
Yeah.
Who was, 80-something years old at that time.
Okay, we're looking at this. It doesn't tell you what you're graphing here. But when I look at this equation, I see x's and y's. Do I see any exponents? No. Do I see variables in denominators? Do I see any square roots? So you have to know that's a line that I'm trying to graph. How many distinct ordered pairs do you need in order to draw a line? What's the minimum number of points you need? 2. I agree. You need 2 ordered pairs. That's what they're going to have you do here. They're going to, looks like here they're having you complete ordered pairs to get solutions of the given equation. Then we're just going to plot points. We're making ourselves a little table. Let me make sure 3y equals 2x minus 6. Let me write this down. I'll switch over here. Okay. We have that first line there that they want us to complete. What this is saying, this table is saying, find y when your x value is equal to 0. So when x is 0, You're trying to find y. Well, you have 3 times y equals, what's 2 times 0? What's 2 times 0? 0. So we have 3y equals 0 minus 6 is a negative 6. We can solve this equation for y now. What do I have to do to solve for y? Divide by 3 to give us y equals negative 2. So when x is 0, the y coordinate is negative 2. We just generated an ordered pair that's a solution to this equation. We need one more ordered pair.
In fact, if I can interrupt, this is an ordered pair. 0, negative 2. Looking at the stuff he said, what kind of point did we just find? An x-intercept or a y-intercept? A y. The
We
x
just
is
found
0.
To find the y-intercept, you let x be 0 and solve for y. Now go back to the equation and type in, we're going to try to go,
What was that?
negative 2. Okay, and now they're going to give us another line on this little table. You tell me, let me write it down. You have a 0 here. We have a little blue box here. What's that telling me to do? Come back to my paper, Tony. What's that telling me to do? This line here, you tell me what it's saying to do. So we're going to let y be 0. The 0's in the y column now, so we're going to let y be 0. We're going to have to find x. 3 times 0. I think y'all can tell me what the left side's going to be when I plug in that 0. 3 times 0 is 0 equals 2x minus 6. I need to solve for x. I'll move the minus 6 over to the right by adding it. What am I going to do to get x by itself? Divide by 2 to give us x equals 3 for my second order pair.
X is 3. Let me punch that in. 3. Check that answer. Okay. Oh. See, there's your ordered pairs. I don't know why they have to have this big, all this up down there. I'm going to make it a little smaller. There. Okay.
Okay. Now,
First time to use one of these.
what I'm going to do, we don't use this grid that's here, okay? What we generally do is we click to pop out the graph. This is the one that I like to use.
The yellow rectangle tells
Expand
you.
that little yellow rectangular box. Click the graph. Choose a tool in the palette and follow the instructions to create your graph. Now, show them the palette, Tony. This stuff here is the palette. Which one of these is the line tool? If you hover over this second, the one that he's hovering over right there, it says line tool.
Can I make it bigger or not?
Yeah, you can make it bigger. You'll
I'll
probably have to make it smaller in a minute.
Yeah.
But there it is, the line tool. And if you look real closely, there are 2 blue dots and then the gray line there. Those 2 blue dots, that's saying you're going to need 2 ordered pairs to draw your graph. You click that tool, and now let's see what the instructions say.
Oh.
Click the first point to plot. The first point we found was 0, negative 2.
Do y'all see the upper right-hand corner of the yellow rectangle? Do you see how it's moving? It's telling you what point I'm on. There'll be some of them where the numbers are so close together, you really got to look up there to see where the point is.
As a matter of fact, when I'm plotting, I don't even look at the grid. I'm looking at do y'all see the order pairs changing up there? Point at it, Tony. Point right there. Do you see? That's what I'm looking at when I'm graphing because some of the grids are going to be extremely
So the
tight.
first one is 0, -2. Am I at 0, -2?
Yes, you see where it says 0, -2 under the big X? Show them where it says it, Tony. Oh no, because if you move it, it's going to change. So you click it. You already clicked it, okay. Now as he moves his mouse around, that it's drawing every possible line passing through 0, -2. Well, the other point, they want the second point. That's 3, 0. Go to 3, 0 and click it.
Am I on 3, 0?
Yeah.
Look in the
Yes.
upper right-hand corner of the yellow rectangle. I click it. And now, let me make it a little smaller so you can see. You can't check it on this screen.
You have to save it. Saving it transfers it back to the original grid, and then check answer.
Okay, so now it's there. I'll say check answer. Okay. Any questions on this? If there's no exponents, no absolute values or square roots, it's a line. What about this one?
Looking at number 2, is number 2 going to be a line? 4x plus 5y equals 20.
Yes.
Yes, as a matter of fact, it's written in standard form. Put it on my paper. It's an ax plus by equals c. We have the x's and y's on the same side. Up here we don't have them on the same side, but it's still the
You could have done it.
You could have. We could have just moved the 2x over and gotten them on the same side, but we didn't need that. Look back at the problem now.
Look, it doesn't have the XY table.
It's not making an XY table. Here you're doing ordered pairs, but it's still the same thing, okay? So first of all, let me see. Here's the ordered pair we have. And they have a little blue box for us right here. You tell me, what is this saying to do?
Find the y.
Okay, we're going to find y when we plug in 0 for x. So we're going to let x equals 0. 4 times 0 is 0 plus 5y is equal to 20. 0 plus 5y is just a 5y. I imagine a lot of y'all just would skip over that and go straight to 5y equals 20. What do I do now? Divide by 5. Divide by 5 to give y equals 20 divided by 5 is 4. So we've just found our first ordered pair, 0, 4.
Let me type that in. Wouldn't this be a better example if that 20 had been a 40?
Why would it be a better example? Oh,
you wouldn't just, because here it looks like you're just getting the same number here, but that's just because of the number. I mean, that's the look of the draw.
Okay. Now we're going to draw. Hey, let's see what the second. They have to tell us something else. We need to get 2 ordered pairs. Look at the next ordered pair they're giving us. What is this ordered pair telling us to do?
Y equals 0.
Let y equals 0. So we're letting y equal 0. That means we have 4x plus 5 times 0 is equal to 20. So we just have 4x equals 20. So what will x be? 5, I agree. So there's my second ordered pair, 5, 0.
5 is 0.
Any question? Oh, we're not through. We have to draw the graph. So click to, we like to enlarge, expand the graph. I think it works better like that. And let me open up the instructions. Wait, where'd the mouse go to? Oh, there it is. Oh, it's not going to move. I was trying to help you out, Tim. I think
Thank
I
you.
just slowed you down.
No, no.
The first ordered pair is 0, 4. Well, that first, point to the first tool in the palette. This thing here, if you hover over that says object selection tool, we'll never use that, okay?
Huh.
We're going to use the others, but in the course, but there's no time you'll ever use the object selection tool. There's only one thing that looks like a line there. Click it, the line tool.
Oh. Let me see if I can lower this a little bit. Did I raise it up too much?
Yeah.
Oh, wow. I'm just making it even. I'm going to say cancel and open it all up. There. Now, Control Shift.
No, you don't need to blow it up anymore.
I'm just going to blow it up one time. Once you're ready to check it, I'll
Okay,
make it
we
small.
click the line. The first tool we have is 0, 4. The first order pair is 0, 4. The next one, 5, 0. That means go to the right 5, up 0. And
Control Shift.
what? Keep going. I think you went up.
No, I went minus. Control Shift. What's going on? Shift.
Okay, there. Save it. But if you use the pop out, you have to save it before you check your answer. Any questions there? The second shape that we're going to be graphing, quadratics. Uh-oh. If something's quadratic, what's the biggest exponent in the expression? A square. So a quadratic would be in the form y equals ax squared plus bx plus c. The name of the shape that's generated from a quadratic is a parabola, P-A-R-A-B-O-L-A. And we're going to spend quite a bit of time with parabolas in a few weeks. We have a whole section devoted to parabolas and their applications. But for now, we have a 3-point tool that we'll be using, a 3-point tool. And a parabola is a smooth U shape. The ones we're graphing will either open upward or downward. But when you look at an equation and you see that x squared, you should expect your graph to be a U opening up or down. Technically, they could open left or right, but we're not going to be graphing horizontal parabolas. This thing is called a vertical parabola, by the way, because the opening is either up or down. And we're going to get all sorts of nice generalizations for quadratics as we move through that section that we'll be seeing in 3 weeks' time. But for the time being, all we're doing is just plotting points. They're going to give us some x values to plug in, and we'll use those x values to draw the graph. This is, hold on, let's go on. Number, is it 3? Yes. But I'm not going directly in the order of the, I'm not going in the order of the assignment. I'm jumping around. So I have a little notes here telling me which one to do next. I'll do number 3. Okay, we want to graph the equation y equals x squared plus 3. And they're giving us a table. They're saying complete the following table of ordered pairs that are solutions of the equation. So they're giving us an XY table. Look at this table. They've given us this table that they want us to complete. I see that x squared, so that says it's going to be a quadratic. So I'm going to have to use the quadratic tool when I'm drawing this graph. For lines, they'd give you a number to plug in for x, and they'd give you a number to plug in for y. In this case, are we going to be plugging in any numbers for y?
No.
No. The numbers they're giving us are all x values. That's nice. It makes it easy. So we'll start off with -2. We're plugging in -2. So that says y is equal to -2 squared plus 3. -2 squared, that's a 4 plus 3. So when x is -2, the y value is +7. Any questions on our logic there? The second row on the table, what is that telling me to do? Plug in 0 for x. So we have y equals 0 squared is 0 plus 3. What are we getting for y? Just a 3. So there's my second ordered pair. The last ordered pair, we're plugging in 2 for x. So we have y equals 2 squared plus 3. 2 squared is 4. Look at that. We're getting the same thing. Whether we plug in the -2 or +2, we're still getting a +7 for y. Any questions there? We're just filling in the table first.
Patch those numbers in there. Oh. 7,
3.
3, and another 7. Check the answer. Okay.
You know something? I think that needs to be shrunk down a little
Oh wait,
bit.
let me close this down. There.
Okay. So click the box to enlarge the graph. Expand the yellow box. Okay. We know this is going to be a U-shaped figure because it's quadratic. There's only one thing there that looks, a tool that looks like a U-shape. That one that he's hovering at there, if you use your bionic eye, you'll see that it says absolute value tool. That's not what we have. An absolute value graph is a V shape. To me, a V has a sharp point on it. This thing is going to be a U shape. Go down into the U-shaped figure. Hover there. What does that say? 3-point quadratic tool. We have 3 ordered pairs, and it's quadratic, so that's the tool we want. So we click that tool, and it says plot the first point. -2, 7.
-2, +7. Am I at -2, 7? Yeah.
Yes. So click it. Now, the next point is 0, 3.
It says plot the second point. So what'd you say, 0, 3? Yeah.
Now the third point, notice as he moves the graph around, as he moves the mouse around, it's starting to draw every possible parabola that contains those 2 points. But the third point, 2, 7, that should get us an accurate picture of the graph. Locate 2, 7, click it, and save it. That transferred it back to the original grid, and then you check your answer.
Any questions? You've got to know which graph or which tool. How did he know quadratic on this? The x squared. Okay.
Number 7. It says graph y equals 2x squared. This is another quadratic. How do I know it's quadratic? That x squared that appears there says it's going to be a U-shaped figure. So what did they not give us? They just tell us to draw the graph. What have they not given us? You choose the numbers yourself in that event. My advice to you, use numbers that are easy to plug in, that are close to 0. For my, in this case, I think I will use, I'm going to make myself a table. I need 3 ordered pairs. I think I'll use -1, 0, and +1.
You could use -2, 0, +2.
You could use -20, 0, or -20, 10, and +20 if you wanted, but realize, look at that. It's only going to let you go 10 units, up, down, left, or right. So the numbers you use, you got to make sure you can't decide, oh, I'm going to use 20 for x, because you won't have 20 on the x-axis. So the numbers,
even though there's a 5 on the x-axis, you can't use 5
because that'd give you a y value of 50.
5 squared is 25 times 2. No, so
just use something real close to 0 and you'll be fine. Plugging in -1 for x. I bet y'all can do that without even showing any work. Plug in -1 for x. -1 times -1 is +1. Times 2 gives me, okay, I better write that out. Y'all seem sort of reluctant there, so we plug in the -1 for x. -1 squared is a +1. 2 times 1 gives me a y value of 2 for my first ordered pair. Now my second ordered pair, this one I think you can do in your head. Plug 0 in for x and tell me what you get. 0. It'll be 0 squared is 0 times 2 is 0. Now plug in 1 for x. What are we going to get? I agree. That's a 2 times 1, which is just another 2. So they may not always give you the ordered pairs, in which case you choose your own numbers to plug in for x, but you are restricted. They have to be numbers that are going to give you y coordinates that can be plotted on the grid.
Like up here on this one, we used -2, 0, 2. We were given those. Could we have used -2, 0, 2? Well, 2 squared is 4 times 2, 8. That's okay. But what about a 3? Theoretically, we can plug a 3 in.
But it wouldn't fit on the grid when you're ready to graph it. Let's go ahead and graph it.
Okay. I'm just going to say click to enlarge. And it's not a line. It's not a V shape. There's no absolute values. There's 3 points, or we found 3 points, and it's quadratic. So there. And
-1, 2.
Left 1, up 2. Am I left -1, 2? Yes.
0, 0.
0, 0. Okay.
And 1, 2.
1 up 2. Am I 1, 2? Yes.
And save it to transfer the graph back and check your answer. So we've graphed, I said there are 5 figures we're graphing in this assignment. We've done lines and quadratics. The next one, Roman numeral 3, cubics. a cubic can be spotted because the biggest exponent it has to be an x cubed. The equation must contain x cubed. Now, when you have those x cubes, you've really got to be careful if you're having to choose the numbers to plug in, because if you try to plug in 10 here, 10 cubed, 10 isn't that big. When you cube it, you're getting 1,000. There's no way they're going to let you plot a y value of 1,000 on the grid. So I think fortunately they're going to give you the numbers they want you to plug in.
Okay, so which
Let's see,
number is this?
number 6.
Oh. Ah, there it
For
is.
the equation y equals x cubed plus 6, create a table of ordered pairs and graph the equation. So I'm going to come over here. This is number 6. Y equals x cubed plus 6. And they give us the table they want us to plug in. Let me write down that table.
For cubics, they always give you the table just because the numbers can get so
I know
big.
they have to. The numbers can get very big very quickly. -1, 0, 1, and 2. Okay.
Bless you.
Y'all called up? Are there any questions?
Okay, switch to my page. Oh, let's see. I need to move this thing there. Okay. Here we go. Let's get started. The first line says plug in -1 for x. So we're plugging in -1. That says y is equal to -1 cubed plus 6. What's -1 times -1 times -1? -1.
Mm-hmm.
So we have a -1 plus 6. What's that giving me for my y value?
5.
5.
Put those in parentheses. Would it look better? Or not?
Y'all think it'd look better if I put parentheses around that? I think it'd just make it look a little busy. I mean, busier, messier, if you will. Now let's plug in 0 for x. We get y equals 0 cubed plus 6. 0 cubed is 0 plus 6 gives me a y value of 6. I bet y'all can do this next calculation in your head. Plug in 1 for x. What are we going to get? I'll tell you this much. We're not going to get the same thing we did when we used -1. But the quadratics, we were getting the same numbers, but I don't think we'll get the same number here. What are you going to get when you plug in 1 for x?
7.
1 cubed is 1 plus 6. I agree with 7.
That's right.
And now let's plug in 2. Let's plug in 2 for x. We're plugging in 2 for x.
Now be careful.
So we have y equals 2 cubed plus 6.
I was about to say, be careful. 2 cubed is not equal to 6. What's 2 times 2 times 2?
8.
8. Okay.
Mhm.
8 plus 6. We get a y value of 14.
Oh,
Huh.
let me look back at that little screen. Oh, wait, they haven't shown us the graph yet. Okay. So what was it? 5?
5, 6, 7, and
6,
14. For a moment,
7, 14.
For a moment, if an equation represents a line, when you increase your x value by 1, the y value is increased by the same amount each time. And so for a moment at 5, 6, 7, it looks like this thing's going to be a line. But when x gets to 2, boom, we're already up at 14. If x were 10, we'd have a y value of 1,006. So we expect these cubics to get extremely steep very quickly. So
Look at how this graph is
I
drawn.
don't like
I don't
that.
like
Do you
this.
see what they've done? They've made it real narrow on the real wide on the x-axis. But look how narrow the intervals are on the y-axis. So be careful when you're graphing the thing.
Oh, wait.
Okay. Blow up the yellow box.
Yeah, but
Don't
help
blow
me
it up.
figure out
Oh,
which one. Okay, line. Nope. How do I know it's not a line? The x cube. It's not an absolute value equation because there's no absolute value bars. You'll know the absolute values when you
When you-
get to them.
because the absolute value bars will have to appear in the equation. It's
Okay.
not a cube. It's not a square.
There's no, it says 3-point quadratic. Well, no, we don't have 3 points and it's not quadratic.
Move
How many
over
points do we have? How many ordered pairs do we have?
4. There it is.
look at
Hover
this.
over it. 4-point cubic tool. You're using 4 ordered pairs, and it's a cubic. So you click the graph of the squiggly. We'll call that little shape a squiggly for a lack of anything better to
Yeah, there's
call it.
no fancy name like parabola. So
Now
plot
the
the
first
first
point, -1, 5.
-1 up 5.
Click.
Click
0, 6.
0. Might 0, 6. It's hard to
Yes.
tell, but I'll look in the
Are
rectangle.
y'all looking at that yellow rectangle? That's where you can see where the pointer's located.
Oops,
Nope.
I think I moved. Okay.
There, 0, 6. The third point is 1, 7.
1. No, that's
go
1,
down.
8.
There. For one moment, look, it looks like it's a line. Those 3 points could be on a line, but eventually, the fact that we're cubing these numbers, it's going to eventually start getting very steep, and I think it's going to do it right now. The order pairs 2, 14. Right 2, up 14,
That's 213.
2, 14. Click it.
You see, these things here where it's a line, that's just sort of the flattening out and changing, concave down, concave up.
Save it.
They're
And-
squiggly.
Yeah, it's a squiggly.
I had a class once that voted to give it a name, and they decided squiggly would be the name of a cubic.
Any questions there?
But you've got to know
What you're
Tool.
graphing in order to use the correct tool.
so there's a lot of thought work going up here. Okay,
Absolute value. Absolute. Oh, this is Roman numeral 4. We had Roman numeral 1. Where is it? Lines. Quadratics.
Quadratics.
Cubic.
Cubes. Cubic.
Now absolute values.
Should you put in parentheses? Trickiest tool. This
Oh,
is going to be
yes.
the trickiest
This is the
one.
trickiest tool because with all the other tools, you just plot the points in the order in which you find them. Here, you're going to have to plot the points in a specific order. The graph of an absolute value will be a V-shaped figure, not a U-shape. To me, a V has a point down there, a sharp point.
Called a vertex.
Called the vertex. It'll either open upward or downward. When we're working with parabolas in more depth in a few weeks, we'll see that parabolas have vertices too, okay? A low point and a high point, but they're more discrete. They're just, you got to sort of just eyeball it up there, okay? The high point and the low point. But with an absolute value, the vertex is obvious. It is a sharp point. And here's the thing, for the graphing tool, you can't just plot the points in the order in which you find them. You must plot the vertex first. So you're going to have to figure out what point is the vertex. You must plot vertex first. That means you're going to need to know which ordered pair is the vertex. How do you do that? Okay, here's how you find out where the vertex occurs. The vertex of an absolute value equation occurs when the inside stuff is equal to 0. Before I write that down, show them number 5 so they can understand what I'm trying to say. Look at the absolute value equation. Y equals the absolute value of x minus 3. What would you have to plug in there for x to make the inside stuff be 0? What x value would make that inside stuff equal 0? 3. So the vertex is going to occur at the ordered pair where x is equal to 3. Come back to my paper and I'm going to write that down. Now that I've tried to show you what we're saying here, I'll say the vertex will occur when, instead of saying the inside stuff is equal to 0, I guess that's not very mathematical. I better say, let's see, the vertex will occur when
The stuff inside the absolute value.
the expression inside the
That sounds
absolute
better.
value, that sounds fancier, right? The expression, I should have just said stuff, inside the absolute value bars is equal to 0. You must plot the vertex first. And if you follow the instructions up there in the little yellow box, if you pop out the graph the way we're doing and they give you those instructions, you'll click the V-shaped figure, the absolute value tool, and then it's going to say plot the vertex. So it tells you that you don't just plot the points randomly, you've got to get that vertex plotted first. Let's look back at number 5. Was it y equals the absolute value of x minus 3?
Mm-hmm.
Y equals the absolute value of x minus 3.
That's not 1x minus 31.
And they're giving us the x values to plug in here. So that's a negative 2.
I think we're going to give you 3 points.
Mm-hmm. Okay. First thing let me ask you something. What did y'all say? When does x minus 3 equal 0? Let's just make a note of where the vertex is going to be right now. X minus 3 equals 0 means that x is equal to
3.
So they're going to have to give us a 3 here to plug in because that's where the vertex will occur. Negative 2 is not the location of the vertex, but they want us to find that ordered pair. Let's plug in negative 2 for x. We'll do that first. Plug in negative 2, so we have y equals the absolute value of negative 2 minus 3. What's negative 2 minus 3? Negative 5. So y is equal to the absolute value of negative 5. What's the absolute value of negative 5? Positive 5. Don't forget to take the absolute value. That's the common mistake here. Y equals positive 5 from a first order pair.
I wonder if I incorrectly put, and this is a common mistake, negative 5. I forgot to take the absolute value. Is it just going to say wrong? Or will it say, yeah, it just says wrong. Okay. But you've got to take that absolute value. So 5. Now look at this one.
Here's the next row. Look at what number they want us to plug in. They want us to plug in 3. And we know that's where the vertex is going to occur. I'm going to make a little note of this right here. There's the vertex. You know something? This is the easiest number to find, the y value to find. Plug in 3 for x, what are you going to get?
0.
0. 3 minus 3 is 0. The absolute value of 0 is just 0.
Put a 0 here.
Now the third point, they want us to plug in 14 for x.
That number should have run.
Yeah.
Where they got the quad.
I'm not sure why they chose 14, but
Okay.
ours is not the question why. We're plugging in 14 for x. So we have y equals
I think
the
they did that
absolute
because they want you to
value
look like you're
of
writing 1,100.
14 minus
I mean,
3. Okay. There. What's 14 minus 3?
Not hard.
11. So we need the absolute value of 11.
See, that's why they chose 14. They want to trick everyone because it looks like you just wrote 1,111.
My students know it's the absolute value of 11, okay? So my students are smart. They know that it's saying the absolute value
It
of
looks
11.
to me like you
which
wrote
gives me-
114 minus 31 up above it, right? Equals 1,111. I'm hoping that your
Shut
students
up.
know their math better than you because 114 minus 3 cannot be 1,000 something.
Okay,
No,
I'll
I'm
make
just-
my absolute value bars bigger.
They're
Okay,
just
what's the absolute value of 11? 11.
Mhm.
Okay, there.
Type that in. See if I got it right.
This graphing tool that we're going to use here for the absolute value graph only requires 2 ordered pairs. These V shapes are symmetric. So we click the graph and we click the absolute value tool. That's a line. There it is. Click it.
Well, I wanted to
Expand the
see-
yellow part so they can see
Yeah.
what the instructions say. Ah, there it is. They say click the graph to plot the vertex. You have to know that 3, 0 is where the vertex occurs. The vertex occurs when the inside stuff is equal to 0. So we plot 3, 0 first.
3, 0. You do not just plot that first point. 3, 0. There. Y'all
There it
see what
is.
I mean about
Click.
it being sort of hard to tell?
Look at the yellow box under that big X to see where your pointer is located at any given time. So click it.
I've clicked it.
Now, Tony, start moving your mouse around. Look at that. It's drawing every possible absolute value graph that has a vertex at 3, 0.
Every
Notice how
D.
it's symmetric. The right hand, oh, I'm getting dizzy watching that. Stop it.
Oh,
Okay. Every one of these things is okay.
Stop.
I'm going to take the mouse away from you, Tony.
Okay.
Every one of these is symmetric. The right-hand side is the mirror image of the left-hand side. So it's taking advantage of the symmetry. Notice we only have to plot one other point. Look at the instructions. Click the graph to plot another point. We found 2 other points, -2, 5 and 14, 11. But we only need one other point. How about we use, which one do you want to use? You'll get the same graph either way. I think let's go to -2, 5. Tony, plot -2, 5 for us.
-2, +5.
Oh,
Is that it?
click it.
I'm at -2, 5. So
Yes.
There.
And notice if we counted 14, 11,
12, 13, 14.
and we went up 11 units, we'd hit that yellow graph. That 1411 is on the graph also, but you only use 2 points for graphing an absolute value, the vertex and one other point. Click Save, and
You know what?
No. You tell me what.
No, forget it. No.
Number 8.
Oh, wait.
Uh,
Oh, wait. No, this
Oh,
is that's a different one,
yeah,
right?
it's different. No, say, help me solve it. Change the problem, okay?
Okay, don't write that one down. I want to change. See, get something other than 3. Oh, look at all of that.
Gosh, I didn't know these things were that long.
How about
Okay.
that?
Okay, this is better. This is number 8. They want us to graph y equals the absolute value of x plus 4.
What's missing here?
This reminds me of that second parabola we drew. What did they not do?
Give us a
They didn't give us the table. They didn't tell us what numbers to plug in. It's up to us which numbers to plug in. I'm only going to make 2 ordered pairs, the vertex and one other point. Let's find the vertex. When is that inside stuff equal to 0?
Not at +4, but
negative.
At -4. So for the vertex, you say x plus 4 needs to equal 0, so x has to equal -4. So there's our little, we're going to make a table. We have to plug in -4 for x. That's going to be where we have the vertex. I'm going to write out vertex. Plugging in -4, what are we going to get for y? It should be easy. 0, okay. Now we need another point. Choose another number to plug in for x. You can use any number you want to. You could use 50 million, but it wouldn't fit on the graph. So my advice to you, choose something close to 0. What do y'all want to plug in as our second x value? I couldn't hear you. 1, that's a good one to use. Plug in 1. 1 plus 4 is 5. The absolute value of 5 is 5. So we have a vertex at -4, 0, and then we have an additional point of 1, 5.
you could plug any number other than -4 in for that second point. 1 is a good one, okay? If you plug 0 in, you would have gotten 4 for the y values. But I like using 1 just so we don't have so many 4s.
Yeah. Scary how we think alike. I was thinking the same thing. Okay.
Okay, I'm going to click to enlarge and choose the absolute value.
It's a V shape, and if you hover, it says absolute value tool. Click it, and they want the vertex. -4, 0 was the vertex.
-4. Oh, I was going to +4.
-4, 0.
And
now we need another point. Our other point is 1, 5.
All of these.
Look at that. It's drawing every absolute value graph that has a vertex at -4, 0.
Wow.
I know it. We're the only ones amazed by all of this.
I forgot, what was the other point?
1, 5.
1.
But back when we were in school, something like this.
The science fiction.
Yeah, just science fiction.
Well, I assume that the federal government had stuff like
Of
this.
course, they'd had more stuff, more advanced stuff. We just didn't.
Not us.
Not us.
1, 5.
Save it. Check answer.
Oh, wow, this is such a good assignment. You're learning so much math. If you can do this assignment, oh, wow.
Okay, any questions on absolute values? We've graphed lines, quadratics, cubics, absolute values. Our 5th shape that we're going to be graphing, square root expressions. So Roman numeral 5. square roots. This book does not have a square root graphing tool built into it. Some MyLab courses do have a square root graphing tool. This isn't one of them, okay?
Well, I
So
didn't
that means
check.
it's going to
Have you
be,
looked?
oh wow, suppose they changed it.
Which one is it?
Square root is number 4.
Hmm.
Now there's not a square root graphing tool, so we're going to graph this thing just by plotting points and then drawing the graph on paper and choosing the graph that's the closest to the one that we found. So y equals the square root of x minus 2. You're going to have to choose the numbers you want to plug in for x. But here's something that you need to remember. Imaginary numbers are imaginary because they can't be labeled on a number line. You can't decide, oh, I'm going to plug in 1 for x. 1 minus 2 is a negative 1. The square root of negative 1 is I. So whatever x values you plug in, you cannot get imaginary numbers. So I'll say no imaginary y values.
So you can't plug a 0 in for x.
You can't plug in a 0. Could I plug in a negative 5 for x? Would that give me a real number? Negative 5 minus 2? No, that's a negative 7 under the square root. What I do to graph square roots is what I ask myself with absolute values. With absolute values, I ask myself, when is the inside stuff equal to 0? And that gives me my vertex. What I do with square roots, I ask myself, when is the inside stuff equal to 0? And that gives me my starting point. So when is x minus 2 equal to 0? Well, when x is 2. So you're going to have to use 2 for x. Here's my xy table. We're going to have to plug in 2 for x. Now, one side of 2 is going to make imaginary numbers. The other side of 2 is going to give us numbers that aren't imaginary. Now, say you tried to use 1. 1 minus 2, that's the square root of negative 1. No, you can't use that. So you can't go to the left of 2. That means you better choose numbers bigger than 2. We could use 3. We could use 4.
How do you know you can use them? Well, 3 minus 2 is a positive 1.
4 minus 2 is a positive 2. Well, what are we going to get when we plug in 2? Let's finish off this first order pair. What are we going to get? 2 minus 2 is 0. The square root of 0 is 0. Okay. What are you going to get when you plug in 3?
1.
Okay. 3 minus 2 is 1. And the square root of 1 is 1. If you plug in 4, 4 minus 2 is 2. Well, the square root of 2, can we simplify that? No, we're just stuck with the square root of 2. Since you're choosing the numbers to plug in, my advice to you, use numbers that'll give you perfect squares. If I plugged in a 5, do I get a perfect square? No. What about 6?
No.
I think it does. If you use 6,
Plug a 6.
plug in a 6. What are we going to get? Okay, we're plugging in 6.
One of the things that makes this particular problem difficult is the way you got to choose the numbers yourself.
6 minus 2, that's a 4. So the square root of 4 is 2. So if I were you, I'd plug in numbers that will give you perfect squares under the radical. And I'm going to draw this by hand, And then we'll look at the four multiple choice options and choose the one that looks the closest like our graph. Here goes. I'm going to draw it by hand. I'm going to make myself a XY grid. And remember, 0 is at the point of intersection. Go 1, 2, 3, 4, 5, 6. Then up 1, 2, 3, 4. I'm putting some little tick marks over here to the left, but is any part of the graph going to be over here to the left? No, but I just think the graph looks better, it looks more balanced if I put the little tick marks there. So that's 1, 2, 3, 4. There. Is any portion of the graph going to be below the x-axis? Are we getting any negative y values? I think the whole graph is going to be right up here in this upper right-hand quadrant. We start off at 2, 0. There's our starting point. Then we go right 3, up 1.
Looks like a line.
And then the square root of 2, is that about a 1.4?
Yeah.
Yeah, because 14 times 14 is 196. So 1.4 times 1.4 is 1.96. That's close to 2, but why bother with those decimal approximations? Just skip over that 4 square root of 2. You have another point, 6, 2. So 6, 2. It starts at the starting point and it goes and it gradually increases. Think about this. When you're way out here at 102 on the x-axis, if you plugged in 102 here, 102 minus 2, 102 would be way over there close to that table. Yeah, it'd be close to that table, but how far up would we be? If you plug in a 102 for x, what are you about to get? 102 minus 2 is 100. The square root of 100 is. So if you plugged in 102, that'd be way over there, okay? You'd only be up to about right here. So it's increasing, but it's increasing very slowly. It started, the graph's starting point is when this inside stuff is equal to 0. Let's look at the 4 graphs. Oh, let's see. Do that. Make it out. Is that it?
No.
No, certainly not. That's a parabola.
Let's go to C.
C. Okay.
Yeah.
I think that's another parabola. I think we can discard those two also. I mean, that one also.
Which one do y'all think it is? Is it
B.
D?
B.
Oh,
B
B.
like boy.
Okay, that's how it's good.
Let me talk into your good ear, Tony.
Now, look at this. Each little mark is 2 units. So there's 2, 0. 4 up 1.4.
Okay.
Let's see, 2, 4 is up. What was
We're
it?
6, 2.
2. I wonder why they incremented by 2 like that. I would have preferred them just 1 unit. But okay.
That's it. Mm-hmm.
There's nothing. Well, I guess it takes some thought up here because you gotta, for the square roots, you gotta figure out the numbers to plug in. Okay.
Any questions? Now we have a couple of new formulas for us, okay? That's related to graphing.
Okay, so 1, 2, 3, 4, 5, 6,
Okay,
7,
so
8.
we did all of the graphing problems, right? Okay.
Do I want to show the problem, or are you just going to state the formula?
I'm going to state the formulas first,
Okay,
okay?
let's put it back over here.
And let's suppose we have 2 arbitrary ordered pairs. 2 arbitrary ordered pairs. Let's suppose we have this first ordered pair I'm labeling right there. And to indicate it's the first ordered pair I'm writing down, I'm going to use subscripts. X subscript 1, comma, Y subscript 1. And then, and out of laziness, we read that as X sub 1, Y sub 1. I just read it as X1, Y1. I don't bother reading out the subscript, just X1, Y1. And I suppose we have another point right here that we'll label, since it's the second order pair I'm labeling, I'll label it X sub 2, Y sub 2, or X2, Y2.
So we have first X, first Y, second X, second Y. Sometimes people read this as X squared. No, those aren't exponents.
They are subscripts.
All it means is second X, second Y, first X. That's what those subscripts are.
Let's draw the line segment connecting these 2 points. There. We have 2 formulas that we're going to use. The first one I want to mention is the distance formula. The distance formula, if you had one of them old-fashioned measuring tapes, you started here and stretched it to the second point. Start at the first point, measure to the second point. That gives us the distance. That length is equal to the distance from one point to the next. It's the it's the shortest distance, as if you drew a line between the two and measure the length of the line. The second formula we're going to have is for something called the midpoint. The midpoint, you look at this line segment, what point looks like it would be right in the middle between the two? It would divide the segment in half. Right out here, it looks like the distance from X1, Y1 to that red dot is the same as the distance from the red dot to X2, Y2. This point here, right in the middle of the segment, is called the midpoint. Now the distance formula.
Here's the formula.
D is equal to the square root of second X minus first X, X sub 2 minus X sub 1 quantity squared, plus Y sub 2 minus Y sub 1 quantity squared. It's interesting, that distance formula can be derived pretty nicely using the Pythagorean theorem. Drawing in the legs, the vertical and the horizontal, and then using that old Pythagorean theorem, a squared plus b squared equals c squared. And when to solve for that distance, you have to get rid of that square. That's where the square root comes from. Now the midpoint formula. The midpoint formula, you're wanting the number that's midway between x1 and x2. You want the number that's midway between y1 and y2. Well, how do you find the number that's midway between two given numbers? I suppose you have 100 and a 90. You have 100 on one test and a 90 on the other test. Well, your average would be 95 because 95 is the number that's midway between those two given numbers. So for the midpoint formula, you're just averaging the x values and averaging the y values, the midpoint formula. Well, to average two numbers, you add them together. So you're adding the x coordinates, dividing by 2. And then you average the y coordinates. You add y1 plus y2 and divide that by 2. And
see how you're adding the two x's and dividing by 2. Isn't that how you would average two numbers? And you average the two y's.
You add them up, divide by 2. So let's see.
Which one are we going to do? 9 or 10?
9, I guess.
Wait, okay, I want to do one that has a lot of negatives in it. Oh, well, no, I think this one. 9 is the better example.
I think it is. You're right.
Mhm.
Look at this. For the point P, -20, -22, and Q, -13, -19, find the distance. Notice that notation they're using, lowercase d of PQ. So that's their algebraic way of saying find the distance from point P to point Q and the coordinates of the midpoint M of the segment PQ. This is number 9. Let me write down the ordered pairs.
-20, comma, -22.
Okay, there's my first point. And now the second.
-13, -19.
Okay. Now, think about how them old measuring tapes work. If you put the measuring tape here and stretched it to this second point, wouldn't you get the same length if you put the measuring tape, you started here and stretched it over this way? So the distance from A to B is the same thing as the distance from B to A. So it doesn't matter which ordered pair you think of as x1, y1, and which one is x2, y2. What I do is the first one I write down, that's what I think of as x1, y1. The second one I write down, I think of as second x, second y. And we'll find the distance.
Just like the quadratic formula.
I'm going to rewrite it.
Mhm.
Remember, it's second x minus first x quantity squared plus second y minus first y quantity squared. And
It seems like there's so many times when we do these in classes and there's no negatives.
I know. I don't know if that means that the
Maybe-
program's
Maybe I
been
made
changed, or is it just a random rare occurrence?
for those.
Do what? Red? Okay, I'll use red. Okay, is that what you said?
Yes. Uh-huh.
Okay. x2. x2 is -13
Be careful.
minus x1 is a -20.
Y'all see why I'm saying you got to be careful?
Watch out, the minus from the formula. And that minus there, we're gonna have to simplify that in a moment. Let's go ahead and fill in these numbers. What number am I gonna write right here? -19, the y2 value, I agree. And here, -22. Continuing, working underneath that radical. -13 minus a -20. Remember the double negation property. That becomes plus a positive. What's -13 plus 20?
7.
So we have 7 squared plus -19 minus a -22. What do I have to do? Okay, so that minus a negative becomes a plus. What's -19 plus 22? -19 plus 22 gives me 3. I agree. Now let's perform, the order of operations says you work inside the parentheses first. Now we do the exponentiation. 7 squared is 49 plus 3 squared is 9. 49 plus 9, that's a 58. Is 58 a perfect square? No. Let's see, are there any perfect square factors that divide
Time
evenly?
to go back to
Page 1. Any perfect square factors that divide evenly into 58? Other than 1? I don't think so. It's 2 times 29 is the prime factorization, and there's no repeated factors. You're just stuck with the square root of 58 as your answer. Well, we're stuck with it. Any questions there?
So no perfect square divides evenly into 58.
Okay, now the midpoint.
Wait, I think I gotta put that
Oh,
in.
they're gonna make you, yeah, okay.
Square
The square
root.
root, remember you get the square root symbol from the toolbar, and then a 58 underneath there. Okay,
Okay.
and now we want the midpoint. Remember for the midpoint, you're just averaging. Average the x coordinates, divide by 2. Average,
Add.
add the x coordinates, divide by 2. Add the y coordinates, divide by 2. So, here you're adding, not subtracting. Okay. X1 is negative 20 plus, what am I going to put here?
Negative 13.
Negative 13, I agree. The second x. What am I going to put here?
Negative 22.
Negative 22, the first y.
Are y'all caught up? Y'all see what he's doing?
A second y here.
Negative 19.
Negative 19. Negative 20 plus a negative 13. Negative 20 plus negative 13, is that a negative 33? Negative 22 plus a negative 19, is that giving me a negative 41?
Yeah.
And there's no common factors. 33 isn't divisible by 2. 41 isn't divisible by 2. I'd leave it right here. I would not convert to mixed numbers. I certainly wouldn't convert to decimals. I think you would count it wrong if you converted to decimals.
But just for the sake of argument, 33 over 2 is 16.5. So the number right between negative 20 and negative 13 is negative 16.5. The number on the number line right between negative 22 and negative 19 is
Negative 20.5.
negative 20.5. Okay. Now,
Any questions there?
Negative 33 over 2. If you notice me doing something wrong, I just did. I should have put that comma down there. Comma, what was it? Negative 41 over 2. What's going to happen here?
We need the parentheses. That's
Say
right.
look.
And when you're doing your homework, you know, oh, I didn't put my parentheses. Let me correct it. Can you do that on a test? No.
Well, if you retake it.
Well, yeah, if you retake it, you can put the parentheses then, but
At the end of
Not
our
a
exam
pen.
or in quizzes, will it give us the answers right away? Or do we have to wait a little bit?
no, it'll give the answers. It'll
Click
show the answer.
I mean the grades.
It'll
sorry.
show the correct answer. If you miss it, it'll show the correct answer. You have to click that correct answer to see what you typed in. People think, oh, the answer that's showing that's marked wrong is the answer they typed in. No, they're showing the correct answer.
And I'm
So,
going to show them a Canvas announcement
okay.
about that in a moment.
Any questions? Okay.
Number 10 is the same thing, but fewer negatives. So I want to just close this up.
What about the recording?
Oh, shoot. I'm going to go ahead and stop the recording now. Are there any questions you want recorded?